Students, we are doing questions from concepts of physics by HCVERMA volume 1, chapter 3, rest and motion, kinematics, and we are doing questions from objective 2. This is the 10th question, students. The acceleration of a particle as seen from two frames, S1 and S2, have equal magnitude. Here it is mentioned equal magnitude. And then the options are given, we have to choose which option is correct. So students, first of all, we have to understand that this particle, whether it is at rest or moving, that is not mentioned. Whether it itself is having acceleration also, it is not mentioned. But acceleration of particle with respect to S1 frame, vector, this is vector, and its magnitude is equal to acceleration of P with respect to frame S2, that is equal to 4 meter per second square. The directions are not important as when you are focusing on magnitude. Now students, the frames must be a part. The frames must be at rest with respect to each other. This must be means that we have to should be 100% sure that they must be at rest with respect to each other. But it is not necessary, students, because if there is a particle P at rest here and frame S1, let it be a car, it is accelerating with 4 meter per second square like this, and car S2 with an acceleration 4 meter per second square like this, particle P at rest. Both of them will perceive that acceleration of P with respect to magnitude will be 4 meter per second square. Okay, so the frame must be at rest with respect to each other. That is not correct. So this is not correct. This is possible. Therefore, must is not correct. The frames may be moving with respect to each other, but neither should be accelerated with respect to the other. That is saying that the frame neither should be. This should be, we have to see that now. I am saying that we can have a situation like this, S1, S2, 4 meter per second square, and this also 4 meter per second square, and this is particle P. This is also possible. This is also possible. This is also possible. And another situation is also possible, which is also a little surprising, like this, that P is here, S1 is moving away like this, and S2 is moving away like this. This is also possible. They are moving perpendicular to each other. So the frames may be moving with respect to each other, but neither should be accelerated with respect to each other. That is, their AS2, AS1 relative to S2 should be 0. That's what AB is demanding. That is not correct. In this, only in this situation, they don't have acceleration with respect to each other. In this situation, they have acceleration with respect to each other. In this situation, they have acceleration with respect to each other. Therefore, B part is also not correct. C part, the acceleration of S2 with respect to S1 may be either be 0, in which case it is 0. In this case, it is 0. Acceleration of S1 with respect to S2 is 0 in this case, and acceleration of S1 with respect to S2, here it is 8 meter per second square. But I have already told you a scenario like this is also possible, in which it is having some value between S1 and S2. So, or it may be any angle. I just put 90 degrees. It is not necessarily 90 degrees. It can be any angle. So, acceleration of this, so maybe either 0 or 8 meter per second square. This is also wrong. So, acceleration of S2 with respect to S1 may be anything between 0 and 8 meter per second square. Students. The printing mistake there. This is the correct answer. I hope it is clear to you, students.